Hello everyone, I am the Chem guy and today we are diving into equations of motion. Equations of motion. Now, why are we learning about equation of motion? Equation of motion describe the relationship between an object position, velocity, acceleration, and time. So it means that it helps to determine an object position, velocity, acceleration, and time. Actually, they basically help us to understand and predict the motion of objects under various forces. Okay, so and we have about four main equations of motion that we are going to learn about. Number one, we have v equals to u plus at. Now, v here means final velocity, u means initial velocity, and a stands for acceleration and t for time. Now, equation 2, s equals to ut plus half at square. All right. Then v square equals to u square plus 2as. Then number 4, s equals to u plus v into bracket t all over 2. All right. So but we are going to learn about how to derive these equations. So we start with the first equation, that is equation 1. So let's learn how to derive v equals to u plus at, that is v equals to u plus at. So how do we derive this equation? How do we derive this equation? It's very simple. We know that acceleration equals to change in velocity over time. Change in velocity over time. That is, when you say change in velocity, it means initial and final. It's a state function, just the initial and final. So initial, let's represent final. So that's final v minus what? Initial all over time. All right. Now, and we know that our acceleration is also denoted as a. So we can just bring it here and say a equals to v minus u all over t. Okay, so if we cross multiply, we are going to have at equals to v minus u. Now, our aim is to make v the subject of the formula. So what do we do? If we had plus u here and plus u here, okay, we have u here and we have u here. So minus u plus u minus u plus u, take care of that. Then we have v equals to u plus 80. So this is how to derive the first equation of motion. The first equation. Now let's learn how to derive the second equation of motion, that is s equals to ut plus half at squared. So how do we do that? It's very simple. We know that average velocity, that is average velocity equals to u plus v all over 2. That is initial plus final velocity all over 2. Okay, or we say, and we can denote this as our v subscript average, that is v average. Okay, but you also recall that in our first equation of motion, equals to v equals to u plus 80. All right, so we will now substitute for this v in this equation. Substitute for this equation in this equation. That is, we replace v here with all this. So doing that, so we have v average equals to u plus, open the bracket, u plus 80, close the bracket, uh, all over 2. That is, if you open the bracket, you are going to have u plus 80 all over 2. So v average equals to u plus u, that's 2u, plus 80 all over 2. So, they are all sharing this denominator together. 2u and 80 are sharing this denominator together. So if you separate them, so that will be 2 here, 1. So that will be plus u plus um, 1 over 280. All right. So our v average equals to u plus half 80. So let's say this is equation 1. So that's equation 1. So now we also know that v average, that is average velocity, can also be distance, that's s, all over time t. Okay, distance s all over time, that is uh s over what, v average equals to s over t. Now let's say this is our equation 2. Now let's equate equation 1 and 2, because v average here is u plus half at, and v average here is distance over time. So it means that uh, s over t equals to, when you equate the two equations, s over t equals to uh, u plus half at. But our goal is to make s subject of the formula. Our goal is to make s the subject of the formula. So what are we going to do? We are going to multiply all through by t. So if we multiply all through by t, let's say we are multiplying all through by t. Sorry about that. So we multiply all through by t, multiply all through by t. So t here, t here. All right. So we will left with s equals to u times t plus half at. Now t times t, that is t square, half at square. That's how to derive the second equation of motion. All right, but you can state categorically that you equate equation 1 to equation 2 while doing your working. Come to the third equation. Now, how do we derive this equation above, equation of motion? That is v square equals to u square plus 2as. So how do we make the derivation? It's very simple. We recall that our first equation of motion is v equals to u plus 80. Hmm? V equals to u plus 80. So let's square both sides. So square both sides. Square both sides. So if you cross both sides, that will be v square equals to, we open a bracket, u plus 80 all squared. Now, how do we expand? Well, this, you know, remember the mathematical identity that when you have a plus b into bracket all squared, so it is going to give you a square plus 2ab plus b square. Remember that identity. So in this case, this is our a and this is our b. So it means that v square equals to u square plus 2, that is 2 u at plus 80 all squared, plus 80 all squared. Now, what we want to do is that we want to introduce s in this equation. We want to introduce s, that's distance, in this equation, so that we get this. Now, what we are going to do is that we write v square equals to u square. So we are going to factorize 2a from this, 2a from these two equations. So plus 2a into bracket. So you factorize 2a, you'll be left with ut plus, but we have 1a here. I mean, we have 2a here, that is a squared. Okay, but we don't have 2 there. But let's write it first. So that is 80 squared. 80 squared. But we don't have 2 here. Do we have 2 here? No, we don't have. So how do we do it? That once you open this equation, once you open it, once you expand it, we are going to get back this. So you're just going to put 2 here. That is half. All right. All right. Then close the bracket. So, and we recall that s equals to u. Recall s equals to ut plus half at square. S equals to ut plus half. So substitute for s. Substitute for s in, let's say this is equation 3, or let's say s this is equation 1 in equation 1. So split for s in equation 1. So we now have v square equals to u square plus what? 2as. So this is our s here being replaced. Proved. Okay. Now let's move to the last equation. Now, let's derive our last equation of motion. That is number 4 equation of motion. We have s equals to u plus v over 2 in bracket times t. So how do we derive this equation? It's very simple. Now, recall that as used earlier on, we said that average speed, average speed, average velocity equals to distance over time. Okay. We also said that average velocity is equals to u plus v all over 2. Okay. So let's say this is equation 1 and this is equation 2. Now let's equate equation 1 and 2. So let's equate equation 1 and 2. It is 1 equals to 2. So it means that we're going to have s over t equals to uh, u plus v all over 2. Okay, but the aim is to make s the subject of the formula. So what do we do? So we just multiply both sides by t, so that t times t, yeah, we take care of each other. Then we're left with s equals to u plus v all over 2 all in bracket t. So this is how to prove the equations or derive the equations of motion, and it can be used to solve problems regarding position of objects, acceleration, time, and